Welcome to the Virtual Interactive Lab Disease. This is from Annenberg, which is a foundation devoted to educate people around science issues. And this particular interactive virtual lab has to do with how population density, how population mixing, and the actual type of contagion can cause disease epidemics and pandemics. So let's go off to the next slide. Okay, so this is the website that you're going to be going to, and the first page is going to have an overview lesson on the virgin field, step 1, 2, and then the virgin field for your consideration, and then vaccination step 1, 2, and 3, and for your consideration. And lastly, pandemic step 1 and for your consideration. So what I've done is I've copied and pasted that content into the PowerPoint because I think it's easier to read and it's easier for me to obviously go over. So in this particular case, what they're talking about is that organisms that cause disease, they co-evolve with us. And sometimes they mutate and change and they have the upper hand. Sometimes we develop drugs and vaccinations and treatments and we have the upper hand. And then it goes back to the pathogen that again can mutate and cause another epidemic, and so it goes. There are two places where you can get a lot of very accurate, very up-to-date information about the coronavirus, and that is the Center for Disease Control, the CDC, and the World Health Organization, because it's a pandemic, it's a worldwide phenomenon. So we are going to explore 4 diseases. These are mock-ups. These are not the real thing, but the way that the simulation runs is true to the situations that you are going to choose. So you can make accurate predictions about what perhaps we should or should not do. So virgin field. A virgin field, and by the way, I'm presuming that you've already read this, so read the PowerPoint before you listen to me. But a virgin field is a group of people that have not been exposed to the disease. So they are virgin. And so the population usually is, you know, I wouldn't say relatively low, but the population has not been exposed. So that's the reason for calling it virgin. So what we're going to do is we are going to go into their simulator. And the simulator, when you click on that website, is on the upper right hand. And I'm hoping that when I get to the last slide, I can hit that and it can bring me to the simulator and you can see it. But it's very easy. It's very, but I will obviously explain what you're going to be doing. In the simulation, you're going to have certain populations of certain density, low, medium, high. You're going to have they're interacting with each other as a low, medium, high mixing of the populations. And then that would give you the number of deaths, the number of infected, the number of immunized, and so forth and so on. So you're going to have to create a table. Now the table could, just be Microsoft Word table. It could be an Excel table. It could be a, try again, I'm trying to think about other ways. A bullet list. That's one of the other things. So you don't have to be sophisticated in knowing how to use Excel or Microsoft Word. Bullet points will also work. The whole idea is that you need to record the data because you're going to make certain conclusions, and those conclusions have to be backed up by data. All right, so we've got these virgins. Now, the virgin field, the first one you're going to do is something called a KOLD, a cold. They just I don't know, make it a little bit different so that you're not saying that this is how colds spread, so they have a theoretical cold. And what you're going to do is you're going to set the simulator for virgin, you're going to set it for cold, and you're going to run that data, and it runs automatically. It goes from day 1 to day 100 and then stops. So you can record all of your information. So what you're going to record is the number of, and these are approximations, the number of dead, immune, at risk, and contagious for day 20 and for day 100. They want you to do it 3 times. And that gives you a chance to do it 3 times, get kind of used to the program, and get your table going. And then you're going to, again, make sure it's at virgin field, run the simulator for the 3 times. What this paragraph is really all about is that the cold, you are told in the details, if you hit that, it lasts 5 days, its transmission is 10%, but the death rate is 0. Okay, so once you've done that and you've got all of your data as far as your number in your virgin field, then what you're going to do is you are going to answer the following questions. All right, so one of the questions is, when you did that, did you get the same results? And the answer is going to surprise you. You would think, okay, everything should be the same. I'm just rerunning this. But what we're going to find is that, look at the red dots. Those are going to be 3 red dots, which represent the people who were initially infected and are starting to spread the disease. You're going to find that they are randomly chosen, so that when you run the first simulator, you're not really running it quite the same way because the 3 dots are in a different position. So it then is going to affect how it's spread. You may find trends to be the same, but you might find that the numbers are different. So I'm going to let you do that. So do you get the same results each time? And what factors might contribute to the susceptibility of the disease, like how close the red dots are, if they're next to each other, or if they're just 2 or 3 dots away from each other, then that's going to make a more complicated story. Alrighty, so on to the next one. And the other thing I just wanted to mention, because you're getting used to it, we're just going to have a medium-sized population. We're going to have the mixing set to none, and that way you're going to see that the data is not exactly the same in the 3 runs, what can happen, but then you get a general idea that the pattern is the same. All right, up to our next wild adventure. Step 2. Okay, so this has to do with the fact that they feel that the simulation is accounting for randomness, which is really good. And now you're going to do something different. You're going to have your virgin field. You're going to do cold, but you're going to do 3 different things. Now that you've run it under medium with no interaction, now you get to do experiment 2. Low population, low population density and high population mixing. Record for day 20 and 100. You only have to do this once, not 3 times. And again, what you're doing is you are in your table for that run. Tell me how many dead, immune, at risk, and contagious at day 20 and day 100 for that trial. The second trial, medium population with high population mixing, and you're going to, again, record day 20 and day 100 for those parameters. And then once you've recorded that and reset the simulator, the third experiment you're going to do is high population density and high population mixing. Again, tell me on day 20 and day 100 in your table for the dead, immune, at risk, and contagious. Now, you've done this now 3 times, and what you've done is you have had a low, medium, and high population, but with a high mixing for low, and a high mixing for medium, and a high mixing for a high population. And now you're going to look at that data and you're going to see differences. And then how do you account for the differences in the results of the last 3 tests? Okay, I can't spell, but that's all right. All right, now this is for your consideration. This is something that I'm going to have you read on your own. It goes into the typical types of diseases that have hit virgin populations, and some of them are quite famous. And then how do you respond to it? Okay, so once we have done that, now we're going to get into the whole issue of vaccination, because that obviously is something that would really help this COVID-19 pandemic that we are experiencing right now, or drugs that are very specifically antiviral for that. But vaccination has historically been a way that people are able to be immunized against a particular deadly pathogen, but without having to contract the disease. It promotes immunological memory. So if the person comes in contact with the real thing, their response is so quick and so immediate because of the vaccination, they're protected and they don't become sick. So we're going to have the influenza. And when you hit the detail button, you can compare the details of influenza with cold. They're slightly up there, and influenza has like a 3% death rate. So for sure, record that somewhere. And now what we're going to do is we're going to do medium population and medium mixing for influenza. Okay, so in the simulator, you're going to select vaccination as a lesson, and then set the vaccination to none. That's going to be a control, and that gives you your virgin field effect. And the population density and mixing are both medium. Okay, so now what you're going to do is you're going to run it. It'll run automatically up to 100 days. You're going to look at day 20 and day 100, and you're going to have numbers that approximate dead, at immune, at risk, and contagious for day 20, and dead, immune, at risk, and contagious for day 100. And then this does go into the fact that, unlike the cold, influenza does have a death rate. And it asks you how many people did die when you ran it with just no vaccinations with the virgin field. And that can just be like one sentence, but that's a question to answer. How does a death toll change? Precautionary factors. What kind of precautions might you take with influenza that you might not have taken with cold? And again, I'm just asking a couple of sentences. And then the next question is, would you consider influenza's death toll to warrant a state of emergency? How high would the numbers have to be for this to happen? And again, you're going to guesstimate that. But now you're seeing these parameters, and when you change them and when you vaccinate, then that will inform you on what you should do to protect this population. So for step 2, this is going to be your second experiment for vaccination. So we're going to, again, choose lesson vaccination, and we're going to do influenza. And we are, again, your day 20 and day 100. When you run your simulation, you should have numbers for dead, immune, at risk, and contagious. So this is going to be medium population, medium mixing, with 50% of the population vaccinated. Reset, and then run it at 90% vaccination at medium population and mixing. And then you're going to sit back and eventually look at the first experiment in vaccination and this experiment. But now you have one more experiment to do. you're going to, again, do vaccination, but you're going to do high population and high mixing. And then you're going to run it, right, for 50% and then for 90%. And then how does using vaccination compare to changing the mixing or the population density? And you're going to find out that under certain circumstances, let's say the death rate is high, or maybe it's going to be the contagious people become elevated, whatever the data is. So I want you to sit with the data and see patterns that emerge. Because from these patterns, with these simulations, which they are doing in the CDC as I speak, they are trying to predict the best case scenario, the worst case scenario, and that's going to inform their decisions. All right, so now we're going to get to step 3. And the reason is that the measles or measles is something that all children have to be vaccinated for before they go to school. And that has to do with the fact that it has a 5% death rate. And the death rate is 5% for children. And that's high enough that a vaccine for measles is definitely what has to happen before the child goes to school, whether that's daycare or whatever. This is just getting a little bit into the controversy that has been around for several years, the anti-vaccination movement, and some of the suppositions. And I have to say that I have some friends who are living abroad, and they feel that homeopathy is a way of dealing with it. I have other friends here who are, definitely pro-vaccination, and so it goes back and forth. One of the things I do want you to know about is something called herd immunity, because you've heard about that quite a lot when in the news. It was mentioned as a strategy for people in the UK. Their herd immunity was a little bit different. It was more, okay, so it was more that if you had the susceptible people get sick and die of the disease, the people who were left would have immunity to it, and that would be their herd immunity. That's not really where the term came from. The term came from the fact that if you vaccinate the majority of the people in a population, then individuals that are sensitive or weaker and have not been vaccinated, in that population where the majority have been vaccinated, the herd, like a herd of cows, a herd of vaccinated people, will buffer or protect that person against getting that disease. Okay, so in the meantime, what are you going to do? Well, you're going to go to vaccination, but you're going to change your pathogen to measles, and then you're going to go into medium population. And I'm on the wrong thing. Okay, here we go. Medium population. Sorry, I didn't know I hit that. Medium population. And you are, okay, so that just tells you what the details are. It's on the next slide. Okay, so now you're going to do measles with medium population, medium mixing, and do it for a virgin field, then do it for 50% vaccinated, and repeat it with 90%. Record all of that, come back, and do it again. But the measles, besides the virgin field and the 50% vaccination, now do it high population and high mixing, and you're going to do it for the 50% and then the 90%. So you'll have your nasal data, you should have your virgin data, what happens if it doesn't, right? For the medium virgin data, for the high, and then you're going to go back to medium population, medium mixing with 50% vaccinated, do it again with 90%. Then you're going to do the same thing for the high population, the virgin numbers, and then you're going to do the high population, high mix at 50% vaccination, high population, high mix for 90% vaccination. And just like you've done before, because the data should all be the same, you should have your day 20 numbers and your day 100 numbers for your dead, immune, at risk, and contagious. Now, you've done a lot under vaccination. So I want you to sit back and look at everything you've done. How does using vaccination compared to changing the mix or the population density? Is it more effective, high, medium, whatever? You're going to get that from your data. And use your data. As you can see in this run, this is different than in that run. And then compare your measles and your influenza. And, they may be the same, but they're probably different. And why? All right, and that's for your consideration as far as vaccines go. You can read that on your own. And then last but not least, pandemics. So now we're in a pandemic with COVID-19, and what we're going to do is use Red Death, not Black Death. Red Death. This is a new disease, and there's no vaccine, and the death rate is high. So Red Death, the person is sick or contagious for 10 days. 50% transmission rate, and a death rate of 20%. Okay, so what you want to do is you want to do your controls, your virgin fields. So you're going to run a medium population, medium mixing with your Red Death, and no vaccination. That's going to be your baseline. You're going to record that. Again, you're going to record for 20 days, 100 days, and the dead, the immune, blah, 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 blah. So then you're going to reset it, and you're going to do medium and medium with 90% vaccination. I'm sorry, 50% vaccination recorded, and do it again, medium, medium with 90% vaccination. Ta-da! And so forth and so on. Okay, so now that you've got your medium, you're going to do the same thing for high population and high mixing. So you're going to have your virgin, you're going to run and record it for 50% vaccination, run and record it for 90% vaccination. And then what are you going to do? You're going to answer the following questions. For this section on pandemics, compare and contrast your data and support your conclusion with the data you collected. There should be a paragraph for what do you get when you look at medium results with and without vaccination. And you might get a better result with 50, less a result at 90, who knows, right? That's going to be a small paragraph. The second paragraph is going to be, how do you interpret your high results, either with or without vaccination, 50 and 90. And then the third paragraph is going to be, compare the medium to the high data in all categories. And what you're trying to get at is, what's going to be the best scenario for not having this spread and kill people? So from this virtual interactive lab, what would be logical ways a population in Boston, we have 7 million, could stop or reduce the spread of COVID-19? So whipping right along, that's pandemic for your consideration. You can read that on your own. And what the lab assignment paper should look like. You are generating data tables, and that how you generate them is going to be up to you. Be logical, label them, make them such that they're easy for me to see what you got for data. Remember that everyone's going to be slightly different. That's the randomization of this program, but the patterns are going to be the same. And organize that. You have your virgin fields, you have your immunization, you have your pandemic, and you did the experiments, you collected a lot of data, and show that data, label it up really nice. Then there are, for each section, questions that you need to answer. And then after you have the data, you can then have question 1 under virgin fields, blah, 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 blah. Question 1 under immunization, blah, 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 blah. And question 1 under pandemics, blah, 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 blah. All right? And then once you've done that, that should be typed, and send it to me as an email attachment on or before March 27th. Now, to open the simulator, you go here, and that gives you background. And then that simulator button, which is on the upper right-hand corner, will bring you to this. Now, here goes nothing. Let's see if this works. All right, I see a little. Okay, so let's see what happens. The gods are good. The gods are not good. Nope. Okay, so since the gods are not good, I will say that if you go to that PowerPoint and you click on that or the simulator, it will bring you to the simulator. And what happens with, oh, there it is. Oh my God, there it is. Yay. All right, everybody see that? So what's happening right now is this is what you see. So you've got your lesson, Virgin Field, but you can also go to vaccination. You can also go to the pandemic. You've got your disease, your Red Death, your cold, your influenza, your measles, right? The details will tell you what aspects of this pathogen, how infective, how it's transmitted, death rate. Then the population goes low, medium, high. The mixing goes low, medium, high. The vaccination goes 5 to 100%. You don't have to deal with the presets. But this is what I mean. These are the 3 red dots of the people who are your patient 0. And then this is going to be your graph. Your graph is going to be in 4 colors, and it's going to go from day 1 to day 100, and it'll take just maybe a couple seconds to do that. So then you can look at the graph and figure out the numbers of dead, of immune, that's blue, of risk, as green, contagious is red. And then all you have to do is hit, that's called a reset button. Part of it's, okay, then you reset it, and then you run it again. And then you reset it, and you run it again. And then all of this changes, and you can see visually how the disease spreads through the population under certain circumstances. And so now I can stop this. So I think I have maybe one more slide. Yes. And that's just showing you, if you go to the website, this is that simulator box. It should be over here. Could not get it over here. But when you go to the site, it will be over here and you'll be all set. And I think that's it. Yay! So enjoy. Email me if you have any questions, and have fun.